Hello and welcome to the short presentation about our paper for HERI-TECH 2022. Today we're going to talk about how trustworthy is an adhesive. This presentation is going to be about the suitability of adhesives for use in conservation fine art. Now, when we talk about an adhesive, fundamentally we're talking about glue. And glue in itself is a polymer, and the polymer composition is the thing that makes all the difference, because you can see that glues comes in all shapes and sizes and colors and strength and fastness and what surface can you put it in, what surface can you not put it on. And fundamentally the most big differentiation is between the vinyl adhesives and the acrylic adhesives, which are distinguished by which one is the building block of your big chain of polymer. Now you can see that here you have a huge possible variability, and depending on what you mix, what you don't mix, you actually end up with a different adhesive. But in this context, we are talking about adhesives in fine arts and conservation, and adhesives are, frankly speaking, one of the best friends of conservators. Why? Because you need them for a lot of consolidations, issues. You need them to actually make sure that everything sticks to the back of your canvas and stuff like that. So conservators tend to have a toolkit of a varied amount of adhesives that they spread on a lot of different surfaces, different adhesives for different surfaces with different thickness, different applications methods. And our study comes into the point of how good is your adhesive, because the fact that your adhesive works incredibly good and in sort of like box conditions when you apply it doesn't necessarily mean that it's going to work all the same and just as nicely as it ages. And this raises an ethical concern fundamentally, because you're treating an object that could potentially, should maybe be treated only once, and you're aging and you might be modifying everything, and also the aging could actually get you to a point in which you find yourself with unwanted results that you couldn't account for in the state that your conserved object looked when you actually applied your adhesive for the first time. Now, in conservator practice, which is not my job, is the job of my conservator collaborators, I am told that you have a box of things that are approved for use because there is the general shared knowledge that they are fine to use. But the scientific prediction that you might try to cross-reference with this statement of this is okay to use are incredibly challenging, even more challenging when you're using commercial products, because the formula of your commercial adhesives is very often proprietary. You are not allowed to know exactly what's in your box, what are your copolymer made of, what are your co-solvents made of. You just know, generally speaking, what's the assignation in that big division that we did at the beginning with acrylic and vinyl adhesives, and that's about it. That's what you need to satisfy yourself with. So in this study, we are going through the scientific evidence associated with the aging of 22 common adhesives, some of them part of conservators' palettes, others just generally commercially available, and we have a huge time span of 10 years and some varied aging applications. In the concept of this study, the first application was done for every adhesive on a series of brush outs, so using laminated opacity cards that allow you to actually see how does this thing is going to look if you just brush it over in a very thin layer. And to account for thicker applications when you actually put a lot of adhesives onto a surface, there was another set of samples prepared for each adhesives on glass slides like the microscope slides. So on one side you have a big drop left to dry, On the other side, you have a brush left to dry on two contrast surfaces that will give you a way to figure out how this is going to look. The study spanned over 10 years, from 2011 to 2021. So 2011 was the preparation and the first analysis of the material. 2021 was the moment when we took it over with a bunch of samples. So these samples actually passed hands a bit, but 2021 is the culmination of the research in which we actually did the final analysis after this sample had been left around. You can see here the list of all of our adhesives. So I promised 22 adhesives, 11 vinyl, and 11 acrylic adhesives. Some of these conservators will recognize them as some like very established fine art conservation adhesives. Others are just commercial stuff that you can literally buy on the shelf, or you could buy on the shelf. Some of these have been discontinued. And what we wanted to know was also a differentiation between what you could actually get from your adhesive in terms of different aging conditions. So one set for each of these adhesives, the one labeled as D, was left in the dark. So from the moment it was actually put on either the slide or the brush out, the samples were kept in a protected environment, no light, just in the dark, aging naturally in air condition without any big variation. This is sort of like our control with a steady aging. This thing could easily reproduce what you actually find yourself with when your adhesive is protected by light because of maybe it's gluing the canvas onto the frame or stuff like that. The other option was the L samples. Every sample that you see here that is labeled with an L was aged first with a huge light exposure. So they were put in a light chamber with UV rich light for 1,320 hours. When you do the conversion with the flux of light that this thing has been exposed to, this is equivalent to an object that has been 18 years into a museum with a standard lighting of a museum. After this treatment, the samples were moved and kept in the dark for the rest of the period. So we will assume that most of the variation happened during the light aging. Everything else is following natural aging. This can reproduce what happens to an adhesive that is actually exposed to the surface because maybe you use it as a consolidant or something like that. And then there was the other option, which was a variation of temperature and relative humidity for the beginning of the story of the sample. So anything that is labeled here as THR is a temperature relative humidity sample. These samples were exposed to 85% relative humidity and 65 degrees Celsius for 720 hours continuously. And then after this chamber treatment, they were put in the dark. So this was the initial treatment, and then afterwards we assume that the aging just went as it follows. This is supposed to reproduce conditions that are not lab conditions, but conditions that could actually reflect environmental arrangements that are different from standard scientific lab procedures. So the first evidence that we can get from our adhesives when we recover them 10 years after aging is how do they look. And immediately, by comparing them with the picture of what we created at the beginning, we can see that this is, for instance, a set of slides of vinyl adhesives. Some of them had huge change in colors, some of them started to crack, some of them started to actually get off this slide. Same business can be done with the brush outs, which again in some cases you see an extreme difference. And as it was done for the vinyl adhesive, you can also take pictures of the acrylic adhesives, both in glass and in the brush out. So this gives you a way to see the macroscopical properties, but it doesn't actually give you an answer as to what is there something going on in the material, or is there something about the substrate or something like that. So to actually test the adhesive as it was, we tested all the samples with infrared spectroscopy. Now, infrared spectroscopy is sensitive to fundamentally the bonds in your material. And every bond will respond differently, and given the tabulated frequency of the variation of the bonds against infrared light, we can have an estimation of what is active in the molecules. We used our instruments in attenuated total reflectance mode, meaning that this thing was suitable for use of an adhesive directly in the solid state. We just scraped from the glass and from the brush out, placed on the IR pin. There is a pressure pin in the IR that fundamentally pushes away a lot of the material. So if you are consistent in your placement on the spot for the sample holder, the fact that there is a pressure pin gives you a way to reproduce roughly the amount of material that you're measuring every time, even if you're not capable of precisely measuring, because we are talking about fraction of milligrams stuff. An initial ATR FTIR was done in 2011. In 2021, we reproduced it at Maastricht University, so caveat that the first collection and the collection 10 years after was done at two different equipment with two different people, and kudos to the several undergraduate students of this group that took all of these measurements. So from the measurements, what do we get as an outcome? You can see the acrylic aging as an original. The original spectra were always in the back here to give us a visual guide of how this thing used to look, and then divided by brush out and glass, in the dark, in the light, and with temperature and relative humidity, which I remind you is only on the glass because of the conditions. So these are the spectra for all the acrylic adhesives. You can see that with some of them you have some incredibly extreme changes that you can immediately spot even visually. Others seems to be holding pretty well. And same business for the vinyl adhesives. Once again, the original is always in the background. There are some that adhere very, very closely to the original spectra, and others that start to show a lot of variability. To actually indicate and give ourselves a guide without having to go through all the spectra every time repeatedly, we actually tabulated the result for, so given the code of the adhesive, either vinyl or acrylic, we gave a qualitative estimation of what do you see in the spectra. Do you literally see no change? Do you see just a very modest dampening that could actually be almost within experimental error, or within the fact that this thing has been aged for 10 years, so the cross-linking will correlate to how well your original chemical structure is altering? More important, do you see a very marked dampening, or do you see some incredibly extreme changes that are the first thing that jumps onto your eyes? So with a very marked dampening, we can assume that something fundamental is changing within our chemical structure, and also that the actual coherence that you have in all the material for this bond to show several times must be dampened in comparison to what you had at the beginning. And we also put an additional flag for the physical changes. So you can also see that regardless of maybe you see a modest dampening, when we indicate a physical change, here we can see that in this case there is a modest dampening of the light aged, but the light age brush out has a very severe physical change that can be either breathless, yellowing, scaling off. So this is all taken into account with this symbol label, and sometimes is all of them have these changes, other times is a very specific flag that we want to give, which is, for instance, the hardening. And to summarize this observation that you will find better unpacked in the papers with a division between also functional group and fingerprint region of the spectra. Here we can see that the light aging in general is something that really affects your adhesives, which is not completely surprising because light is a the photochemical issue with polymers is always true to be. But in some adhesives, you must be careful when using them in very high humidity and hot conditions, because the changes that we see, chemically speaking, are extreme, which will mean that your adhesive will not behave potentially like you were thinking. All the brush outs have some chemical aging reflected in the FTIR profiles. In general, the trend is that if you use a vinylic adhesive, you have a more severe influence, especially in the high temperature and relative humidity conditions or light conditions, in comparison to a good number of acrylic adhesives, which, from the point of view of the FTIR, seems to be okay. And the application method does make a difference. So usually you see less chemical change when you have very thick droplet on the glass in comparison to the thin brush out, but the yellowing will appear regardless of you putting a whole drop or you brushing out on the surface. Some important remarks that come from this study, which is overall qualitative, and we're not trying to do something quantitative bond by bond, because we cannot do that not knowing the full formula of proprietary adhesives, are that there are some well-established and well-examined adhesives that we tested in this study that show a real experimental variance depending on how do you age them. So it is worth checking out the conditions of the aging, because these adhesives that you might think are very well established, incredibly reported in the field, might actually surprise you when you get at the end. Some of the commercial adhesives that several conservators tend to avoid, by right could be introduced in the palettes because they show a remarkably consistent behavior, both macroscopically and from the chemical FTIR. Some adhesives deserve praise for having a consistent and remarkably contained shift regardless of the aging. So these adhesives can be considered very aging resistant. And unfortunately, we have to point out that some of the best formulations that we found have actually been discontinued, and the new formulations don't seem to have exactly the same behavior. So this is also a reminder to maybe test your adhesives, even if you think the formulation should be the same. If they changed the label, they might have changed the behavior in a way that no one has bothered to flag you in conservators conditions. So this guidance can actually hopefully guide you through some adhesives that people have generally very easily available, and could guide your conservator practice into an informed procedure for long-term projects. And given what you can see when you do aging testings, especially when you do them for a long time, is worth taking into account what did we have in the adhesive that performs better, so that when someone tries to develop a new adhesive, especially for conservator purposes, they might find a better formulation that is science informed. Now, thank you for your attention. This study has been a collaboration between the science department of Maastricht University and the Restaurasi Atelier of SRAL, and has involved a lot of undergraduate students, the trainees of SRAL, and two supervisors, me, Giulietta Perversi, and Kate Seymour, who's our conservator supervisor. For more information, with better scientific unpacking and more details, please check out our paper, which is paper 87 in the proceeding. Thank you very much.